Hello, I'm Marcus.
Hi, I'm Gregor.
So this is the first ever episode of OMG Rust. Now this is about the Rust programming language. Now, Gregor, I've just had an idea. Why did we call it OMG Rust?
I don't know.
Because I'm just thinking, what if Microsoft bring out a better programming language called Verona++? Then will we have to change the channel name and call it OMG Microsoft Verona++?
Okay. Or perhaps it means, oh my God, Marcus and Gregor.
Oh, yeah, I think that's a good idea. Yeah. So we're going to talk about a few things today. We're going to give some background about us, and we're going to find out, is Rust just a systems programming language? So let's start with the first ever episode. Gregor and I have been working in the same company for quite a few years now, but we haven't been working together. And I don't know, a bit more than a year ago, I started to work with Gregor on a project, and he became my mentor on this project because he had been on this project for a very long time. So when I got to know Gregor, I told Gregor how wonderful Kotlin was, and Gregor kept telling me how wonderful Rust was. And Gregor, do you remember what you said about Kotlin at the time?
Yeah, perhaps something like Kotlin is a better Java version, or Kotlin is like Java should look like, but it's still Java.
Yeah, so I think that's a bit unfair because I thought Kotlin is so much more than Java, but perhaps you're correct.
Yeah, it's little bit more than Java, and it's of course I personally find it much better than Java, but. For me, Rust is a game changer, not Kotlin.
Yeah, so you kept talking to me about learn Rust. And I kept saying, oh, we should be learning Kotlin. But I didn't really want to learn Rust because I kept hearing it was a systems programming language. And I heard a little bit about WebAssembly, but I hadn't used WebAssembly, and that seemed quite cool. But when it came to Rust, I thought, I'm not sure. So finally, I decided to learn Rust because Gregor's job is to force everybody to learn Rust in the company. Is that correct, Gregor?
That's not really correct. I wish everyone would learn Rust, and I just said to you, Rust is an amazing language. Yeah, and you simply learn it. And I said this to a lot of people, but not all start to learning it. But my experience is whenever someone learned Rust, he found it great. Rust, for example, is the 7th time in a row the most loved programming language on Stack Overflow, and there must be a reason for that.
Would you say it's just a systems programming language, Gregor?
No. So 2 years ago, also Rust characterized itself as a system programming language, and of course, the root of Rust is to replace C or C++, so to replace system programming language. But nowadays, Rust is saying it is a general purpose language, and I personally think it's true. Of course, you can do system programming. You can really manipulate bits and bytes, but on the other hand, you also have high-level constructs in Rust. So it's both. It's a system programming language. You can use it as a system programming language, but you can also use it nearly for everything.
So as a full stack developer, that definitely sounds good. But there's a lot of people saying it's a low level language. And as a full stack developer, you don't really want to be learning low level languages. Is it really a low level language, or does it support high level as well?
No. It's if you want to do low level, you can do low level, of course, but it has a very good function. It's a multi-paradigm programming language. But for example, if you want to program in a functional style, Rust is, I would say, nearly idle. It was inspired by Haskell, a lot of things. And I personally think, for example, the type system of Rust is much better than Java. You have everything high-level programming needed. You have polymorphism, you have functional constructs. So for me, it's both. It's a high-level language, but if you want, you can manipulate bits, and you can do low-level things.
Yeah, so one of the things I did a lot with Kotlin has got something called Kotlin multi-platform. So this is where you write Kotlin code once and it can actually produce Android code. Well, Android obviously is Kotlin, or Java, or iOS code. So you write one Kotlin code base and you can produce the same code for Android and for iOS. And this worked quite well. On the iOS side, well, when I used Kotlin multi-platform, it actually produced Objective-C code. So Objective-C or Swift can run on iOS. So you can put all your business logic in Kotlin, and then just for the screens, you use the native Swift with iOS just to develop the screens, calling the Kotlin code. And on Android, you do the same. Obviously, you use Kotlin to do the Kotlin screens.
Yeah, but if you use native Kotlin, you do not have all the Java libraries, which is of course an advantage of Kotlin, that you have access to the Java libraries. But if you do native Kotlin, you lose this advantage, and the devil is in the details. So on Android, it's compiled to Objective C, and on Android other things. So the approach from Rust is different. It simply produces native code for the platform. There's no intermediate level.
Yeah, that's entirely right, but Gregor, because what I found was to do this, you had to use native Kotlin. And so you can't use common Java classes such as Date. You just can't use them. They've got their own native classes, but there's many, many good Java libraries you just can't use. So it really restricts native Kotlin. I believe Google is looking to improve Kotlin multi-platform. But I just don't think it's there at the moment. And another big issue I had with Kotlin native, so I run some prime number examples so you can download them from the internet, see how quick the programming language is. And Kotlin native was so much slower than Kotlin based against the Java virtual machine. And it was really slow. It was I don't know, 10 or 20 times slower than Kotlin on Java virtual machine. So Kotlin native really is slow, whereas the same prime number example, obviously in Rust, was astonishing. The performance was just astonishing, much better than Java virtual machine, and countless times better than Kotlin.
Yeah, nowadays Java is not bad in regarding performance. As I started with Java, around about 20 years ago, Java was really slow compared to C, but they made a lot of enhancements. So Java is fast, but Rust is even faster, much faster, and it consumes much less memory.
Yeah, that's a good point about the memory, actually, Gregor, because one of the first applications I wrote in Rust was actually to solve a problem we had for a client. So we had a Java application, quite a big application, and it needed to read big Excel files. Now, in the Java world, to read big Excel files, you use a library called Apache POI, or POI, P-O-I. And this must be and the Apache libraries are some of the very best or most loved Java libraries out there. And in financial systems, most financial systems where we work, are going at some point or another are going to need to be able to read Excel files inside of a Java application. So what we found out was that with big Excel files, the Apache POI kept having memory heap problems. And I thought, well, one way to solve this, obviously, is to increase the heap space within Java, and this would solve the problem. But how big would the Excel files actually get? Would this still be a bad problem? And to me, the solution just smelled bad of increasing the memory heap size. So I found a library, or what we call a crate in Rust, called Calamine. And Calamine, I just wanted to try it to read an Excel file, because this allows you to read Excel files in Rust. So yeah, so I read this Excel file. There were no memory problems, no nothing. It was really easy to use this library. And what I basically did was, with Gregor, we wrote a shared library of about 20 or 30 lines of Rust code. And we actually then called the Rust code from Java from the shared library. So now we solved all this memory issues. We got rid of the Apache POI library, and we're actually using a Rust library and using 20 or 30 lines of Rust code inside the Java code. And this was running on Windows and Linux.
Yeah, this was an amazing experience. And another interesting point, if you connect a shared library with Java, you need to implement a JNI layer, and you normally did this with C. And in this project, we discovered another crate, JNI. And so we was able to write the JNI layer also in Rust. And it's writing in C, it's no fun. But writing the JNI layer in Java, it was amazing, also amazing. Yeah, it was simply great because in C I have always struggled with a lot of things, starting from the build system to the different definition, what is an int in which operating system, and so on and so on. The Rust writing this JNI layer, it was a very great experience.
Yeah, and it was very simple because you've actually got a crate to help you write the JNI layer or library in
Yes.
Rust, which actually helps
Yes.
you write it. And some people may say, well, this is a very small example of reading an Excel file in Rust. Would you rewrite the whole Java application in Rust? I would say yes, definitely. But this is an example of small things you can do in Rust just to get to know the language and add it to, for example, Java. But we did this in other places as well. I remember we had some JavaScript Node.js code and we needed to increase the performance. So we wrote some small piece of Rust code and integrated that into Node.js using another library in Rust called Neon. And that just worked. And now we've got Rust code instead of JavaScript code. Just fantastic.
Yes, that was another example how good Rust interoperate with other languages. And normally, if you write a Node add-on to bind, and for example, a library native library to Node.js, you need to do some similar stuff like writing JNI. You need to write a layer between your code written in a native language and Node.js. And we did this with a crate named Neon. It was amazing, amazing, easy compared to the example I saw for C++. So that's another example how good Rust interact or where you can use Rust in different environments. You can use it on Android, you can use it on iOS, you can use it together with Java, you can use it together with Node.js. You can use Wasm to run it directly in the browser, and you can also write a microservice completely in Rust without any programming language. So
this brings me on to our next example, because we've actually used Rust in many places, haven't we, Gregor? So we actually needed to write some iOS code and Android code. And normally I'd jump straight to Kotlin multi-platform, but we didn't. We wrote that code in Rust. Actually, we wrote this code in iOS and Android for a coding competition. That was right, for coding competition. So we actually used Rust. What we did, we're actually reading files from Rust, writing files and calling web services. The code to write files, read files, and to call web services was all written in Rust. We just put that shared library into iOS, put that same shared library into Android, and it just worked. So then from our front end, written in Swift and Kotlin, called this Rust shared library, and that did all the work of calling web services for us, writing to files and reading from files. It was just amazing.
Yes. As I said, Rust is really amazing language. It's yeah, my first love was Smalltalk. Then I programmed more than 20 years in Java. Java is not bad, but I do not. Yeah, it's okay. But Rust is really my second love. It's a really amazing language, and you can do things which you cannot do in Java. And it's simply an amazing language.
And then there's another example we did, isn't there, Gregor, where we used WebAssembly. So we have a big React Redux application that uses React and Redux. And I don't know if anyone's ever used React or Redux, but Redux is a real boilerplate JavaScript framework that uses with React, and it uses a lot of JavaScript code. And we really hate JavaScript code. It should be abolished as a language. It's really terrible. But anyway, what we did, could we replace Redux with WebAssembly written in Rust? And we did, because Redux basically stores the state of the application, of your web application. And what we did, we got rid of the Redux and we replaced it with a WebAssembly written in Rust. We got rid of lots of boilerplate code. We got rid of lots of JavaScript code, and it was just amazing. It just worked, and it was much better than Redux, just by using WebAssembly. Also, what we managed to do was some kind of edge computing, because we'd written some server code in Rust that checked, for example, validations, things like that. We just put that same server-side code, exactly the same code, inside of the WebAssembly. So now we're actually getting the same validations on the client side as on the server side by using WebAssembly with exactly the same code base. That's just brilliant. It just solves so many problems because now we don't have to write validation codes twice. We've got the same code on server and the client.
As I said, Rust is amazing. That's why we try to explain it to the audience.
What is really amazing is it's not a systems programming language because we've used it on mobile, we've used it in WebAssembly, we've used it on the server, we've used it everywhere. We use it as microservices running as AWS Lambdas, as you mentioned, and the performance is just amazing. So I wanted to bring us back to Kotlin. One of the things about Kotlin is that it's clean, maintainable code. That's one of the great advantages of Kotlin. And what I really like about Kotlin, it's easy to write, it's easy to read. But as we said, the multi-platform is a mess. Now, back in the day at university, I was a C++ programmer and I was writing desktop Windows applications in C++. And I used to think I was a pretty good C++ programmer. But then something came along called Java. And I got onto the Java bandwagon. I've still got this mug where it says Java is everywhere. Oh, it still is everywhere, I guess. Java said, write once, run everywhere. And that was particularly true of the UI because everything was going to web. And the idea was you could run on Linux or Windows, the same UI using something called Swing, was it? Swing or AWT?
Swing, yeah.
So I stopped being a C++ programmer and I moved to Java. And in the meantime, I've done other programming languages like Python, etc. But what I understand with Rust is it does exactly what C++ does. C++, you can also run it everywhere. You can run it on mobile apps. You can run it in WebAssembly. You can write shared libraries in it. And I just have come to the realization that all these years I've been writing Java code, and I left university as a good C++ programmer. I don't remember much about C++ now. I've wasted 20 years of my life. I should have just stayed a C++ programmer, as C++ is the future. Because really, it's C++ and Rust, the only two languages really that you can run everywhere.
Yeah, but you do not waste your time. Every programming language opens your mind, and I think there was a reason that Java was successful. This idea, write it once, run everywhere. It's much more complicated than C++. And 20 years ago, C++ was a different language as today, much more complicated. So I don't think that you have wasted your time. At least you have learned a lot.
Yeah, I've learned a lot. I've learned I should have been just using C++ and then move straight to Rust. But anyway.
Yeah, but if you would start 20 years ago learning C++, 10 years or 15 years later, you need to start from new because C++ is nearly more than one language. Every C program is a C++ program, and the old styles C++. Nowadays, we have modern C++. Modules are coming to C++. So C++ is really more than one language. And you have the problem that you do not have a garbage collector. So you have the problem of memory leaks. And by the way, that's one of the amazing things of Rust. Before Rust, I thought, okay, a language either has a garbage collector or you must handle the memory by yourself. But it's not true. Rust does not have a garbage collector, so you can also use it in an embedded system. But it has a clean idea about ownership and borrowing. So you cannot have memory leaks in Rust. That's another big advantage. It's a very safe language. You cannot program memory leaks. You cannot have null pointers. And you cannot have data races, which, for example, you can easily program in Java.
But if I had have stuck with C++ for the past 20 years, I'd have probably spent the last 20 years looking for memory leaks in the debugger.
Yes.
Something else which is painful in C++ is trying to find the libraries and having a clean build system. In Rust, it's just so easy with Cargo. You've got a really clean, easy to use build system, and you've got just a central place where you can look for all your libraries or crates. I mean, that really is something that is fantastic in Rust, I think. I think it's one of the easiest languages to find libraries in.
Yes. Building in C or C++ programs was always painful because there's no standard for it. Some writing makefile, others using CMake. So it's always a problem to build a C program, probably especially when it comes to multi-platform. At the end, you have makefile for each and every platform, and you have to maintain it. And in Rust, you simply say cargo build, and that's it.
Yeah, it's so easy. It's so easy. But there's a lot of people who complain that there's not enough Rust libraries, or they're not of a good quality, or whatever. But we've just given the example of the Apache POI library, where it's much better in Rust to read an Excel file than it is in Java. What do you think about the Rust libraries? Have you come across examples where you can't find any or not? Because I haven't. We've wrote quite big programs in Rust.
Sometimes I have the problem that I don't know which of the crates I should use.
Yes, there's so many to do the same thing.
Yeah, but I do not miss until now. I always find a good crate. And some days ago, I read on Twitter an argument that the advantage to start from scratch with a new programming language is that you can avoid the mistakes made in the past, and that you can learn from previous example. And I personally found the crates of crates are the name of a module in Rust very good, because they mostly do only one thing. Also, the APIs I found much better. For example, take a look at how in Java streams are implemented. Take a look at how it is implemented in TypeScript, and take a look how it implemented in Rust. It's much cleaner in Rust.
Yeah, and another thing with Java is you get some huge frameworks. It's not about are you a Java programmer. It's about which framework using with Java, using, for example, Spring.
Yes, yeah. Spring will try to solve each and every problem. That's typical Java. You create a factory to get an instance, and so on. So Java tends to be always to be a little bit complex and verbose, and in contrast, Rust libraries are really small.
Yeah, they're really small, easy to add. Yeah, and yeah. It's just amazing, Rust. I absolutely love it since I've been learning it for such a small time, and we've done really lots with it. So I definitely think we can say this is not a systems programming language, is it, Gregor?
No, it's definitely not a system. You can use it as a system language, but it is a general purpose language. You can write server-side code, you write client-side code, you can even run your code in the browser using WebAssembly. You can interact with other language. You can write code for Node.js. You can write code for Java. You can write mobile. Nearly every operating system is supported, so it's definitely not a system language. You can nearly everything what you want. And main advantage, in my opinion, is that it's produced native code, so it's there's no overhead. And there's another very important thing in Rust. It's the idea is coming from C++, abstraction with no costs. So every abstraction in Rust is handled by the compiler, and it's the same holds true for C++, and the resulting code, you cannot write the better code by hand. That's the main principle of C++ and of Rust. And that's another difference, for example, compared to Java, where you have runtime overhead because of some abstractions. You can everything what you can do in Java, you can do in Rust, and you can even do more.
Yeah, exactly. And that's why we call the channel OMG Rust and not OMG Java. But yeah, everybody should start learning Rust. It's just a game changer. But I want to come back to Kotlin again, because the Kotlin language designer, Roman, he actually said performance is not an issue. Because Kotlin normally is against the Java virtual machine, and performance is not an issue. He says, even if the code is 20% slower, this doesn't matter, because these problems can be resolved in hardware. So hardware is always getting better. It's always getting quicker. So it doesn't matter that, for example, the code runs 20% slower. What's important is the code is clean and maintainable. And he says, because in Kotlin, you write clean and maintainable code, it doesn't matter if the performance is slower, because the hardware will solve this problem of the performance. So it doesn't really matter. What do you think about his views about it? Performance doesn't matter if the takeoff is you get clean and maintainable code?
First of all, to have clean, maintainable code is the most important thing. That's for true. But the performance problem argument, I heard it 20 years ago as I started with Java. I found Java very good, but was really a disadvantage that Java is slower. And for me, it is not an argument. And for example, if you could look nowadays on writing serverless code, which means that you write a function which run in the cloud on AWS, Google, or wherever, then performance is very important because you pay for each and every millisecond you use. And another thing is, yeah, you need much less energy if your program runs faster. So I personally think the performance argument is not true. The clean code argument, I agree. I totally agree, but not. I would always prefer a language which is fast, given that this language is regarding clean code as good as I expected.
I would say I slightly prefer the syntax of Kotlin, but I think Rust code in a way is cleaner and more maintainable because the Rust compiler doesn't allow you to write bad code. Sometimes you have to fight with a Rust compiler before the code will compile. And this isn't quite the same with Kotlin. For example, you can't have null pointer exceptions in Rust like you can in Kotlin. I know Kotlin tries to resolve that, but not to the same level as Rust. So I think code is maintainable and clean in Rust, just as it is in Kotlin. It's definitely cleaner in Rust than it is in Java, for example, and Kotlin is definitely cleaner than Java. There's another important point here you mentioned is ecological computing. I mean, if we can use fewer resources and fewer hardware and fewer energy, that's definitely better for CO2 and for the climate. And one funny thing talking about this clean code and maintainable code is we wrote quite a big project in Rust, and we had 3 testers on this project, so 3 people from the QA team. And they found very few bugs. And they even complained that they couldn't find many bugs. And these are professional QA testers. It's not like somebody from the street. And they were amazed how few bugs they were finding compared to the similar Java application that they were testing. So I just think that shows you how good and clean the code is in Rust, because the testers can't find code. Obviously, you can write logical errors, but generally, if you know what you're doing, generally you can avoid all of those silly errors, such as memory leaks or null pointers or other silly errors to do with types.
And another experience in this project was we have 2 junior programmers which learned Rust in our project. And it was, for me, amazing how fast they adapt the language and how fast they get productive. And that's another advantage of Rust, because let's say you have a JavaScript program, a junior programmer can simply introduce some subtle bugs which are hard to find at runtime. But in Rust, the junior programmer must able to compile this program. So the compiler do a good job regarding quality assurance.
I think that's the biggest thing. If you've got junior programmers on your team, you can trust more of their code they're writing because the compiler just won't allow them to write bad code. I mean, the classic joke is, where do you catch null pointer exceptions? Well, in production, obviously, isn't it?
Yes.
Yeah. So Rust just stops you doing that. And therefore, because you're not catching these errors in production and you're not coming across all these runtime errors, you're speeding up the development process and you're writing code faster, even if it takes a bit longer to compile. And one of the junior developers actually said to us when they were learning Rust, they said, the thing I love about the Rust compiler is it explains to me where I went wrong and how I can improve that part of the code. It's not just like there's an issue here. It explains to you how you should be doing it and how to fix that issue. It's really descriptive and really well written, the actual Rust compiler. And it's a great place to actually learn Rust.
Yes, that's another amazing point about Rust. I have programmed in so much programming language, but the Rust compiler is really the best compiler I ever used. The hints and the error messages are amazing. It's really helpful.
That's definitely true. And in our company, probably like a lot of companies, we've got a lot of JavaScript code on the client side and on the server side with Node.js. And I just think JavaScript code is the worst possible code. Java is much better than JavaScript code because Java catches some errors that are just not caught in JavaScript code. In JavaScript code, the code just stops and you don't know why. It gives you no warnings, no anything. And a lot of people bring in junior programmers, so it's good they can write JavaScript code. But if you go into a project with JavaScript code, you're just going to spend all your time fighting fires. I really think if you're using a lot of JavaScript in your company, you should be trying to move to Rust. You're going to improve code quality. You're going to make the code more readable, and you're going to improve performance.
Yes, definitely. So you need not to rewrite each and everything, but it's really, really a good idea to start with Rust, in my opinion.
That's given us a good overview, hasn't it, Gregor? How do you think that went?
I hope it was good.
Yeah, so I hope that's give you a good overview, a little bit about Rust. Hope you've understood it's not a systems programming language. I hope you've learned a little bit about myself, a little bit about Gregor. So what we're going to do, we're not just going to do these sessions where we talk. We will have some more talking sessions, but we're going to actually show code. So perhaps we show some examples. How can you replace React Redux with React WebAssembly and Rust? How you can use JNI and call Rust from Java programs, how you can call Rust from JavaScript programs, because we really think it's important. Obviously, you're not going to rewrite all your applications, but it's really important to see how very specific parts of Rust, just to start with, can be used inside your existing applications, and how this can help you learn Rust and really start giving you advantages with Rust and getting along with us. So if you want to see us code, writing bad code, Gregor and I, yeah, we're going to do some coding sessions, and they will probably be the next things we do in this OMG Rust YouTube channel. Please leave your comments below. We love to know what you think about this, and if you want to know something about Rust or something, then just ask us, and perhaps we can include that in one of our next videos. So please click subscribe.
Yeah, click subscribe, and thank you.
Yeah, thank you. Bye.
Bye.